Problem from lesson 5.6, and what we're going to take a look at is how to model this particular situation, and then also use the model or the equation that we come up with in order to figure out how much wood is needed in order to produce this little section of the roller coaster, right? So we have in this question, we have vertical supports made out of wood, and we also have some horizontal supports made out of wood. And then we can just figure out how much wood is needed in total. So first things first, though, we need to be able to come up with a model that represents what I see in the diagram. Okay, and so what you're going to see is the high and low points on the tracker separated by 5 meters vertically and 8 meters horizontally. Okay, and then what you see in there is I went through and counted the number of boxes and just kind of gave you a rough estimate as to what or how far apart each post would be, or vertical support as well. Okay, so the low point is 1 meter below the ground. Okay, and we're going to let y represent the height above the ground and x represent the horizontal distance from the highest point. Okay, so that says each of those vertical supports is going to be a distance of 80 centimeters away from one another. And so that'll become important in part B. Okay, so determine an equation for the roller coaster. What we need to do here, like usual, is just come up with a kind of a model, right? So this looks like to me a cosine curve where I start at my kind of peak and then come down to the low point or the minimum. And so when I try and model this, I'm going to write y is equal to a cosine of k, and in this case we're going to have x minus p, where p is the phase shift, and then plus d being the equation of the axis. Okay, so we can start with the easier things, right? Like a, k, and d. The hard part with these questions, as we learned in the first part of the video or the lesson, was figuring out the phase shift. Now the nice thing about making cosine as a selection as to which graph we're going to model this with is we're not going to actually need the phase shift for this question. All right, so I can get rid of p. Okay, so I don't need to figure that out. There is no phase shift. What I do need to figure out, though, is a the amplitude. So the amplitude is going to be a measurement of the max minus the min and then divided by 2. Okay, and so the max is going to be 4 minus -1 divided by 2, which is going to be 5 by 2. Okay, so that's going to be my a value. K is going to be 360 divided by the period. And if you take a look at the curve there, we go from the maximum to the minimum in a distance of 8 meters, which would mean the full cycle would take 16 meters to complete. Okay, so the period would be 16. And subsequently, if I put 16 in for the period P, I'm going to get 360 divided by 16. K should be 22.5. Okay, now there's one more piece to this, and with the original cosine curve, we have what we call the equation of the axis, and that's kind of like a horizontal symmetry, if you will, from maximum to minimum, and it's located in the middle of the maximum and minimum. With the regular cosine curve, it occurs at y equals 0, where we go from +1 down to -1. That's not the case with this particular question. The equation of the axis would have to be somewhere up in here, right? Some equal distance between the maximum and the minimum. We can find that distance by taking, so if we're looking for the d, or the equation of the axis, we can find it by going, it'd be the maximum plus the minimum, and then divide by 2. Okay, so we're going to get 4 plus -1. Gotta be careful with this one. Divided by 2 is going to be 3/2 is going to be the d value for this. And that is actually the three components that make up the equation. Okay, so we actually get, for the equation that models this particular situation with respect to cosine, we're going to get 5 over 2 cosine 20, actually I don't even need round brackets because there's not going to be a phase shift, 22.5 x plus 3 over 2. Okay, so that's going to be the equation that models what I'm seeing there with the roller coaster. Okay, and if I go down now, the vertical timber supports are 1 meter apart. Okay, so that's talking vertically. How much wood is needed for the vertical supports and how much wood is needed for the horizontal supports. In actuality, if I take a look at that, and I've tweaked this question from what I think it originally was, each box, if you will, this is like kind of like a grid, each box is going to be worth 80 centimeters. Okay, in order to arrive at the fact that there's 4 meters of height from zero, and it looks like there's 1, 2, 3, 4 horizontal supports, right? And subsequently, to get from 0 to 8 meters, that also has to be 80 centimeter intervals. Okay, so we're going to use 0.8 for this. Okay, a little more sturdy, I suppose, if we don't space them so far apart. Okay, so what we need to figure out using our equation is how much wood we're going to end up needing in terms of like lengths in order to support the rails for this roller coaster. Okay, and what I'm going to do is I'm going to show you how to do the math, and then we're going to use another tool like a scientific calculator, or in this case Desmos. I'm going to show you how to use Desmos in order to actually figure out how much wood would be needed, right? So to figure out the vertical, you have an equation, right? An equation that says y is equal to a bunch of stuff. And if I put in a value of x like a function machine, I'm going to get out outputs, right? So I can actually rewrite this in a way that I think helps communicate what it is we're actually solving for, right? So if I have f of x, this is the function notation, cosine of 22.5 x plus 3 over 2. If I was looking for how much wood would be needed at the peak, so right at 0 meters, I could evaluate this function at 0, and I would get 5 over 2 cosine of 22.5 times 0 plus 3 over 2. Okay, and I would find out that the cosine of 0, because 0 times 22.5 is going to be 0, the cosine of 0 is going to be 1. So the evaluation work here is going to be 5 over 2 times 1 plus 3 over 2. The result there is I get 8 over 2, which checks out with what I'm expecting to see, because when I evaluate this function at 0, I expect to see 4. Okay, now if vertical timber supports are 0.8 meters apart, how much wood is needed for vertical supports? That's I'm looking for all of these, let me get rid of the color, all of these blue supports. So I just found one, there's 4 meters, but I want to know how much each one of these ones are worth as well in terms of height, which is what I'm going to do. Okay, and I expect to see it's about 6.2, the curve cross at cross the x-axis. Okay, so what I want to do is use Desmos to help me figure out what is the value of the function at 0.8, what is the value of the function at 1.6, 2.4, 3.2, 4, and so on. Okay, until I get to what looks to be about 5.6 would be the last one, right? So I want to check f at 4.8, and then f at 5.6. Okay, all of these are going to have values. Now, with a scientific calculator, it might not be too bad because you might be able just to go in there and change this entry, or input, if you will, pretty easily, and then just hit equals, and it should just spit out a bunch of numbers. But to take an opportunity to show you how to use Desmos maybe as a tool, we can go flip over here, right? And so what I can do is I can put in y equals, I can put in my function that I've come up with, 5 over 2, okay, cosine of 22 and a half x, oops, maybe I should have put brackets around this. Okay, and then plus the 3 over 2. Now that looks like a wild graph, but what you have to do with Desmos is tell it, instead of being in radians, which is just a different unit of measurement, switch it over to degrees. Okay. Okay, and so you should see, you know, you've got your initial height, and yeah, we're getting pretty close, Okay. So what we need to do here is I can do this little trick here where I can go create a table. Okay. And what I'm interested in is not the negative values. I'm interested in the values of 0.8, 1.6, 2.4, oops, 3.2, 4, 4.8, and 5.6. Okay, so you can see here, if I were to take up these, you know, we've got like almost 4 meters, you know, 3.5 meters, 3 meters, 2.27 meters, 1.5 meters. Like if I took all those outputs and summed them all up or added them all together, that would be the total amount of wood that I would need in order to create the vertical supports, right? And so what I need to do now too is figure out how much wood would be needed for the horizontal supports as well. So that's going to require us to isolate for a different variable, right? Because right now what I have is my equation is isolated for y, right? I have f of x, right? Basically y is equal to a bunch of stuff, right? So what I'm going to be asked for now is what is x given the y values, okay, as I go across there. Okay, and so what I need to do is take my original equation, if I took it and rewrote it like y equals 5 over 2, sorry, I'll go back, you guys can't see that. We have 5 over 2 cosine of 22 and a half x plus 3 over 2. What I need is I need x by itself. Okay, so that's what I'm going to do. I'm just going to back solve to get it, right? And to do that, I need to use my solving skills that I've been working on for the last couple years, right? So I'm actually going to get y is equal to 5 over 2. Oh, actually, you know what? Let's be smart about this. If I took the whole equation and multiplied it by 2, I would get rid of the fractions. Okay? But if I do it on the left, or sorry, on the right, I also have to do it on the left. Okay, and so what I'm going to get is 2y has to equal 5 cosine 22 and a half x plus 3. From here I can go 2y minus 3 has to equal 5 cosine 22 and a half x. Okay. Now divide both sides by 5. So I get 2y minus 3 divided by 5 has to be cosine of 22 and a half x. Now, we've explained a couple times in here and in grade 10 that if I were to, basically what's happening here is I'm taking cosine and multiplying it by that. And what I can do is divide both sides by cosine, right? And if I do that, I get cosine on both sides. If I divide on one side, I have to divide on the other. And then you recall that the exponent on cosine currently is technically 1, or is 1. And what I can do with exponents, when I take an exponent and move it from the denominator to the numerator, I can make it negative, right? And so I get cos inverse of 2y minus 3 over 5 has to equal 22.5 x. And then one final step, it's to divide both sides by 22.5. Okay, and I get x is equal to cos inverse of 2y minus 3 by 5 divided by 22.5. Okay, so if I were to solve for the horizontal supports, or how much wood be needed, I would take x is going to equal the cos inverse of 2y. Well, the first horizontal support is going to occur at 0.8 meters, so I'm going to go 2 times 0.8 minus 3 over 5, and then divide all that by 22.5. Okay, that would give me the support for 0.8. I could do it again for 1.6. I could do it again for 2.4 and 3.2, and then I would be able to add all those up again and then get the total amount of wood that I would need for the horizontal supports. Okay, in total I would take the sum from the vertical supports, the sum from the horizontal supports. That would be the total amount of wood that I would need in order to create that little section of the roller coaster. Okay, so hopefully you found some use in that, between using Desmos and trying to figure out, what are the x values that correspond with y's, and y's that correspond with particular x's, and then applying that to a situation that somebody has been paid to do and figure out, right? So that's that question, the roller coaster question, modeling, and then with a mixture of some solving in there as well. Okay, so it should prepare you pretty good for the kinds of application questions that you would encounter with periodic functions.